It's Tuesday, which means it's Talkin' Science time. Brad and I have got details on 2 exoplanets colliding, a new type of really small black hole, as well as special coverage of Northrop Grumman's Cygnus docking with the space station.
With Dr. Brad Tucker and Matt Miller, this is Talkin' Science on Trekzone.
Well, welcome to Tuesday. Welcome to Dr. Brad Tucker. Happy Tuesday, sir.
Yeah, how's it going?
Really good, really good. Really happy for Northrop Grumman. They've put a rocket into orbit and they've put a space capsule, the SS Allen Bean, into, or docked it with the International Space Station. Let's dive straight into the headlines of the week.
Yeah, no, and it's great that it was successful. And, it's just another one of these groups filling the void of launching and sending things into orbit in the space. It's not that it's crowded, it's busy, and it's good busy.
Exactly right. Well, what I love is what was on board the Allen Bean, this new Cygnus space capsule. One of the things that I love is that an oven has finally been delivered to the space station. They can finally bake some cookies.
The dough comes from the Hilton Doubletree brand. So if you ever stay at a Hilton Doubletree, you always get a cookie upon arrival.
And they are really good cookies. We had them in Hawaii.
Yeah. So they sent that dough into space to be tested. That's awesome. Of how to make a space cookie. I mean, beyond being the most delicious experiment anyone can dream of. I'm getting my head around this, right? You go through all of your years of education and your degrees as an astronaut, your training, you spend years trying to get to an astronaut, then years preparing for your mission. What's on the docket for this week in space? Am I going to be solving the mysteries of the universe, setting the ground for the moon? I'm baking a cookie.
But it is very important research because it's hopefully going to stop astronauts eating space rations, basically.
Yeah, and look, a lot of these tests are all about the setting up independency on future space exploration, right? Not just bringing everything up, not just having freeze-dried food, being able to create an environment where you can do things in space. And one of that is obviously cooking. And it is way more complicated than you imagine because A, everything is more difficult in space, but B, because of that, the changing in gravity and the change in pressure and the way heat dissipates in the capsule and the area of the space station means that all those properties behave differently. And we saw, right, when we talked about this a few months ago with the cement experiment, right, where they made cement and set it in space, and it formed differently because of lack of the weak gravity. This is a big thing to know. Do these little small environmental things change the way things are cooked or baked in space? And that's a big question they need to know.
I wonder whether they had to bring up Earth-baked cookies as well so that they could do a taste testing comparison.
Oh, well, look, I mean, you've got to be thorough, right? You need to control samples. You definitely have to repeat the experiments. This is the essence of science. And in fact, this will pave way for more than just baking and cooking, right? Anything that needs manufacturing of a heat source, thinking of 3D printing, thinking of molding things, those sorts of things, anything where you have to heat or bake an environment and then have that ingredient or that substance change and then set in a certain way when cool, that applies to a lot of different things people are talking about in space. So, it sounds very funny and silly, but at least they can compare and they know the behavior of something like a cookie, and it's fairly safe if something goes wrong.
Well, while they're out there eating those cookies on the International Space Station's sun deck, getting their tan on, they're going to be wearing some safety vests that have also been taken up as well to help them combat some radiation.
Yeah, and again, this is all about trying to test new lightweight materials that are more resistant to the properties of space. We've talked a lot about the issues of radiation that astronauts have, but one of the big questions is there a way that you can solve radiation but also have a material that is lightweight and usable? Right? That's the big question. You can just shield yourself with lead. Well, lead is kind of heavy. So this new kind of lighter material vest how much radiation does it limit, and its effectiveness. And those are big things that people want to know.
And lastly, the other key thing that they've taken up is some parts to fix the Alpha Spectrometer.
Yeah, so the Alpha Spectrometer is one of the new or not new, but it's one of the experiments on board that's been trying to detect essentially when particles decay. So there's a big thing where cosmic rays or radiation from space, when they slowly decay, if you break apart enough ways, what it could mean is that if there's enough, let's say, certain production, there might be a way of actually detecting signatures of dark matter, because dark matter, which is believed to be a particle, a very small particle like a proton, but smaller than that, if it behaves a certain way, this dark matter, it will affect kind of the natural physical processes in space. And the only way to see these radioactive or high energy particles is in space, because the Earth's atmosphere blocks most of these, so you can't do this experiment on the ground. So it's kind of like trying to measure a shower, and the only way you're going to measure if someone's turning off the shower is by holding a bucket and seeing when the bucket stops getting filled or how quickly it fills. That's what they're trying to do, but to look for dark matter.
Some incredible experiments to be conducted over the next few months and years as well. It's a huge kudos once again to Northrop Grumman for getting the 12th Antares rocket up, and a new look rocket and a new look Cygnus as well. It's carrying heavier payloads, which is absolutely fantastic, and it's great that it's made it to the space station. They can now unload it and fill it with their trash and burn it up in the atmosphere.
Yeah, exactly. And look, it's all about multiple suppliers, cheaper, more effective. And look, it's the same way people ship things here on Earth, right? We have multiple companies that have multiple benefits depending on the cargo, what you're sending, how fast you need to get it, and where. And this is the same in space, and it's great to see a lot of these things coming to fruition, which means it will only make space cheaper, more accessible, and more things happening. And so it was a great success.
I do dread that if we are going to keep going with all these companies reaching space for deliveries, if Australia Post gets out there.
Yeah, it would take a lot of stamps to be put on. I don't know how many stamps it is to space, but whatever, if you're sending your package as a kilogram, it'd be about $20,000. That's a lot of stamps.
That's a lot of stamps. Yeah, it's about $3 to get from Brisbane to Perth or something. It's ridiculous. Anyway, let's stop packing on Australia Post, because they do a good job sometimes. And let's talk exoplanets, because astronomers have seen the wreckage from a couple colliding.
Yeah, so, when we think of planets, we think of nice planets orbiting a star in a fairly stable orbit in a fairly stable system. But we have to look at our own solar system. And in fact, when we think of the origins of the moon, we have a belief that there was a collision between a body about the size of Mars, not Mars, but something like Mars, and the Earth, crashed into Earth. This created the moon. And that's because the early solar system, or when we thought any solar systems, there's lots of stuff swirling around, things are colliding, and then eventually enough of these collisions happen and gravity pulls the big things together, and the small things eventually fade away, and then the solar system ends up being essentially cleaned up in a safe place. This new observations of this star system, it appears that two exoplanets has crashed into each other about 1 billion years into the lifetime of the star system. And that's a really long time for this sort of thing to happen. And it might actually challenge the way we think exoplanets come together.
It is incredible, because the Spitzer Space Telescope, about a decade ago, they looked at this system and thought that's a bit strange. And they've come back to it now, and this is where these findings are coming out, that they think that this is what's happened.
The stuff that makes up planets is really dust, is what we call it. It's ingredients, it's the rock, and this rock, is what we call dust, glows in the infrared, because that's where the heat comes from. And by looking at infrared colors from Spitzer and then using new images from ALMA, they actually saw that this glow, or this heat, has increased. So this explosion has actually happened a while, and it's kind of happened. Planets don't collide and explode in an instantaneous second. It happens after a while, they collide, and then the stuff slowly spreads out. And so it might appear that this was, in fact, a collision that happened recently, and related to a star system that's at least 1 billion years old, is probably way too old from the way we think of how planets form for something like this to happen, because we're talking about planets like Earthy, rocky planets, and this should have settled down. So it's a very important discovery if it's held to be true.
And as the astronomers said in the conclusion of their paper, understanding BD plus 20, which is where we're looking, 307, and other systems, can help us advance our knowledge of catastrophic collisions, the effects of binary stars on debris disks, and the evolution of planetary systems, which can include us as well if we stick around for another couple of 100 million years.
Exactly. How, it's important to figure out how we formed, right? This all goes back to our information about the moon. It tells us a bit about things like the asteroid belt we were just talking about last week with Hygeia, and whether it's a dwarf planet or not with its spies. Is the asteroid belt really a more recent collision between things, and these are leftover bits, or it's something that will happen later? This is all important. We keep talking about almost every week how, with our knowledge of planetary systems, it's really just now changing, because this is a fairly new field when we're thinking about it. And our information is literally pouring in daily and changing our views of a very fundamental thing, and that's how planets and stars come together.
Hashtag justice for Pluto.
It's going to be like a theme every show, I think, at some point.
Well, Pluto's just so hard done by, and all my textbooks from my formative years, Brad.
Yeah, look, Pluto. What can you say about Pluto? And look, I'm really interested to see what happens next year. I think there will be a lot of Plutastic discussions.
Yeah, well, I think maybe a call out to Dr. Neil deGrasse Tyson, who was part of the committee that downgraded Pluto, wasn't he?
He was. Alan Stern, who was the PI of New Horizons, which sent the probe to Pluto, has a very different view of what Pluto is. So he is definitely a big proponent of. He's pro-Pluto.
Pro-Pluto. I love it. Well, something else that I think we can be pro about is black holes. I'm talking about the astronomical ones, of course, and a new one's been discovered. It might be the smallest ever.
Yeah, this is really cool, because when we think of black holes, you think of the big ones, the supermassive ones, as we call them. And there are a lot out there. We think every major galaxy has these supermassive black holes, anywhere between millions and billions of times the mass of our sun. And the way we think it happens is we get the small ones, what we call the stellar mass black holes. They explode. So a star explodes, and in the inside, the star kind of collapses on itself to form a black hole. And those black holes come together and merge and collide in gravitational waves and eventually build up to form the big ones. And there's been a limit, we've thought, of how small of a black hole can be created based on how big of a star can create it. And a new observation shows that there might be a much smaller black hole, only about 3.5 times the mass of our sun, which is really small in terms of the size of what a black hole could be, which might change the way we think black holes are created in the first instance.
I love it that the researchers were basically counting the black holes in the galaxy and discovered it.
Yeah, they were essentially just doing a map of what these stellar mass black holes, and were trying to do their mass measurements based on the X-ray light, and found one is really small comparatively. And because this is actually quite important in the internal size of a star. We think on the inside of a star, there's this battle between gravity and pressure, and at some point, pressure, essentially nuclear force, loses, gravity comes crashing down, pulls it into a black hole. We thought if you're too small, instead of forming a black hole, you pretty much form a neutron star. But if it's the case that you can form a smaller black hole, that will change the rate of what neutron stars are created. Or maybe there's a different process in the works of where this boundary occurs, or even with the relative type of star. And then if those black holes change, then the amount of black holes in the galaxy and universe will be slightly different. The rates of these collisions, the gravitational waves can happen. So it really is a very important picture in our knowledge of these extreme objects.
Could our sun, in theory, turn into a black hole then?
I mean, we've always thought that our sun is way too small. And even in this new result, our sun is way too small compared to it. But some of the bigger the medium-sized stars, let's say, the ones where they're less than what we call 8 times the mass of our sun, where we thought the limit was before, maybe they don't, and maybe they do something else. Who knows?
Well, that's good. So all we have to worry about is colliding planets in the solar system, meteorites and asteroids that are going to come and get us. We don't have to worry about the sun.
We don't, and do cookies bake in space. Really the pressing things of our generation.
Absolutely. Well, we've covered the hot topics of the week, Brad. I really appreciate it, and thanks for talking science. We'll catch you next week.
Yeah, no worries. Off to go do remote observing in Chile.
You are?
Yeah, I'm going to start observing in about an hour. And the great thing is, because of time zone difference, I have to observe the first half of the night, which is about from 10:30 a.m. to 3 p.m. my time.
Ah, damn. Don't you hate that?
Yeah, it's so not ruining your sleep cycle. What a terrible, terrible benefit. So we'll see how it goes. Hopefully I'll get clear skies in Chile.
Love it, Brad. We'll talk to you next week.
Thanks.
You can get social with Trekzone. Australia's unofficial home of Star Trek is everywhere you are. Get the wrap up on our Facebook page. Keep in the loop on Twitter and relive Trek episodes on Instagram. Just search for Trekzone.